so this is plus. So the sine of your alpha is minus 3/5. Cosine beta is minus 4/5. Cosine alpha is minus 4/5. And sine beta is 3/5. So that's 12 over 25 minus 12 over 25, which is 0.
Okay.
Anything about that that is unclear or anything that you don't understand?
No, that makes sense.
Okay. And they could give you a variety of problems here. I mean, they could ask you for half angles, double angles, sum and difference. All of them are kind of in play here. Okay, so on to number 18.
Yeah.
Let's look at 18. All right. Okay, so you're in quadrant 2. Got to be able to draw the triangle in quadrant 2. That's mu. Sine is 12 over 13. This ends up being minus 5 with Pythagorean theorem and Pythagorean triples. Those might be worth including on your reference sheet, some of those Pythagorean triples. There's an infinite number of them, but maybe the first few.
Mhm.
Okay, now cosine 2u, there are a bunch of ways to remember that. Do you have one that you sort of prefer here? I'm going to snip them all in.
Do I have a what?
Yeah, do you have one that you prefer? There's 3 flavors of it. You know, 3.
Not
They're all
really.
equivalent. Okay. I mean, they're all the same to me. So I'm going to use the top one here. That's minus 5 over 13 squared, minus 12 over 13 squared, 25 over 169, minus 144 over 169 is minus 119 over 169. These answers don't mean much. You just have to follow through the formulas, I mean, whatever that is, it is.
And then we would leave
That's
it
it.
as
That's it.
okay.
Because that's what they're asking for. Cosine of 2u, 2 theta, 2u, 2 theta. And that's why I said all of these give you the same result. It's just you have to pick one to use.
Okay.
Like the way I used to be, I mean, and I was very curious as students. I'd actually try all 3 until I convinced myself they're all the same. I don't expect you to do that, but you know, you can use any of them. I
Okay.
would write them
Sounds
all down if you had a reference sheet. I would have them all on there because one might be more useful than another in a certain situation.
okay.
All right, on to 19 now.
Mhm.
Okay. So cosine 8 theta, cosine 3 theta. If you go to your reference sheet, if I go to my reference sheet, right? Like the thing that I'm not sure about is what you're like. Sometimes they give you more information about how they want it. Like sometimes they don't want it as a single thing. So I'm not. I think they're just asking you to apply the product to some formula here, where this is eight phi is alpha and 3 phi is beta. So you're just applying the formula here. What I was thinking of is that sometimes they want you to expand this to a single phi and phi, like they don't want any multiples of it in here. And that's why I initially
Mhm.
was like, oh, this could be really bad. Because you have to expand, 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 and multiply. But it doesn't look like that. It looks like they just want you to go 8 phi minus 3 phi plus cosine 8 phi plus 3 phi. So it's 1/2 cosine 5 phi plus cosine 11 phi.
Okay.
I guess. Do you have
So
the
the main thing is being
solutions?
able to find the.
Yeah, like, yeah, I mean, I feel like that's the answer, but you have the
And I
solutions
would
to
leave
this,
it at,
Tim?
and I'd leave it at that.
Yeah, I mean, it says summer difference. We've got that. Like, but it seems way too easy for what you've relative to what you've been doing in the class.
Yeah. Okay, yeah,
But
that's what it says the answer is.
it's consistent with 20. 20 is going backwards now. Now, did your teacher write this or did someone else write this? Like a common one for your school?
My teacher wrote it.
Okay, so here's how some teachers proceed is they give you this one, and then on the test it's sine 8 phi, sine 8 phi. Like they'll switch from sine to cosine. So just that's like if you're wondering like how should I study or what else could I study, you could do the same problems with sine instead of cosine, for example.
Yeah.
All right, so this one is going the other direction. Um, let me get the formula again here. So the challenge here is figuring out, okay, it's alpha, let me write the formula, sorry. Okay, so um, you have to figure out what alpha and beta are. Alpha minus beta is 3 theta, and alpha plus beta is 2 theta. Does that
Y-
make sense? How we're doing that?
Kinda. Yeah.
These don't work out nice, but I mean, they work out kind of okay. So when you add them up, it's 2 alpha equals 5 theta. So alpha equals 5 over 2 theta. And then you put that back into one or the other, and you end up getting beta equals 1/2 theta. Sorry, minus 1/2 theta. Okay, and then you're just that. So this the other way the other
Okay.
thing here is that this formula, you don't have a 1/2 in front. You have just a 1, so you're gonna end up multiplying the other side by 2, or both sides by 2, basically. And so you have to remember that it's easy if it's multiple choice to forget that. So it's 2 cosine 5 over 2 theta cosine minus 1/2 theta. Now, yeah, something like that.
Okay, yeah.
Any questions on that?
No, that makes sense.
All right, so the next ones I see here are, I think you said 24, 25.
Mhm.
Okay. So this is a formula. There is no there's no way to do this without the formula. It's Heron's formula. Have you heard of that before?
Yeah.
So you have to take you need the half perimeter. It's usually called S. So that's half perimeter. It's 3 plus 4 plus 5 divided by 2, which is 6. And then the area is the square root of S, S minus A, S minus B, S minus C. Does this look familiar to you?
Yeah, yeah.
Okay. Um, so that's 6 minus 3, 6 minus 4, 6 minus 5. So we got 3, 2, and 1. It's easy to get, like if you don't remember the formula or something, you could get some negatives in here. That's kind of an indicator you've done it wrong. So this is 1836, which is the square root of 36, which is 6. Now, kind of like off to the side here, the only, well, shouldn't say it that way. This is a right triangle. So the area is 1/2 base times height. But I don't know how you would know that. Like, and you can't, like, it's not guaranteed to be that. So just keep that in mind, I guess.
Mhm. Wait, so you wouldn't have, oh, only if it's a right triangle though.
Yeah, and I mean, it's dangerous to sort of assume that yours would be a right triangle on the test. I believe it's meant to use this formula. This formula always works,
Okay.
but I don't really know why it works. I mean, well, there's some proving you can justify it, but like it, it's kind of an obscure formula only in this course. Actually, it's more of a geometry formula. Like, I don't actually know why it's in this course. Anyway, so 25.
Mhm.
Okay. So I always have to check what this north 47 east means. So I need to look that up because I have no idea. I don't really remember how that works, and I don't want to mess that up for you. Um, East of north. Okay. North. Okay. So this is north, and 47 degrees east of it is here. Does that make sense?
Mhm.
So somehow you have to remember that if you don't already know it. And maybe I'm more speaking to myself. I don't know. I just can't reconcile how to make this work. But you're going 15 miles per hour for 2 hours, 10 a.m. to noon. So that's 2 hours. So how far has it gone? What's this distance?
2 hours. I mean, two.
It's 2 hours. Distance equals rate times time. Rate is 15,
30.
30. There you go. And then south 51 east. So there's south. And then 51 degrees. And it's going 18 miles per hour. So this is 36. How can you calculate the angle between them?
Subtract one from 180.
Now, the reason you need that is because this is a law of cosines problem. Because that's what we want there. All right, so we'll call it C. So could you give me that angle, please?
$82.
82 degrees. Okay. So law of cosines is the reason it's a law of cosines is because it's a side angle side problem.
Mhm.
Do you remember that? You can also use it for side, side, side. So C squared equals A squared plus B squared minus 2AB cosine big C. Do you remember how to use this formula? Do you feel like you have
Yeah.
enough? Okay. So,
Would
it doesn't really, go ahead.
and A would be 36 and B would be
30, or you can switch them. So,
30.
so sometimes it's good to kind of redraw it with only the information you need because you've got like, too much stuff going on there. So we got 30 squared plus 36 squared. It doesn't matter which one is A and B. Make sure your mode is in degrees. Make sure you're always checking that, especially if you're moving back and forth between them.
Okay.
So go ahead and calculate that for us, please. Let me know if you have any questions on how to do that.
$43.54.
And the units might be important, depending on that's miles. All right. Let me know what you want us to work on next.
Um, do we do 35 and 36? Also, what does verifying the identity entail?
Yeah, good question. Do you want us to do those, or is that like we should do one if you're not sure?
Yeah.
Okay. Yeah, give me just a moment here. I get some problems pulled up. Okay, so verifying an identity is it's hard to grade. So do you want us to do 35 and 36
Hmm.
first?
Yeah.
Okay. Okay. Graphing these is easier on, are you allowed to use your calculator?
Yeah.
Okay. Do you want me to show you how to do this on your calculator?
Mhm.
Okay. All right. So I'm gonna new share my calculator here. Um, you have to change your mode to polar. You probably haven't had to do that much. Instead of function, parametric, polar, POL. Is that okay? Have you seen that
Yeah.
before? Okay. So you change your calculator to polar. You go to y equals, and you'll notice it's no longer y equals. Is that okay? You're seeing that here on your screen if
Yeah.
you got a calculator. Okay.
It
Now
was
your
format, right?
mode under function parametric. It's normally function. That's for
Okay,
rectangular
yeah.
coordinates. Parametrics for other stuff you guys maybe have done. I don't remember. Polar and then sequences is SEQ.
Hmm.
Now you can always reset your memory down here, second mem reset if you like get totally you don't know how to get back to your original settings. But you'll want to change that back. So now if you go to your y equals, it's r equals instead of y equals. Your formula is r squared, which we're kind of gonna we're kind of doing a hack here. You're gonna do the square root of the right hand side. So you're gonna do the square root of 49 sine, and then you're gonna do 2, and then instead of hitting x here, it'll turn into a theta. Calculator knows you mean radian, or sorry, polar. Let me know if you have any questions about how to enter that.
No, I got that.
Got it. Okay. So now the window, it kind of already knows to do it in polar. You can go to zoom, and then I think there's a zoom polar. I guess not. All right, so we're gonna go to graph, and you can see it makes this nice, pretty, graph.
Okay.
So that's how you do it with the calculator. There is a way to do it by hand, but it's very difficult and time consuming and stuff like that. So do you want us to go through it by hand?
No, we're allowed to use our calculator, so I think I'll just like stick to this method, but
Okay. Now, what is the name? That's a reference sheet. So these all have names like lam. Let me look them up. There's
the lemniscate.
cardioids, limacons, lemniscates, rows, curves, Archimedes spirals. There's a lot out there, and I don't I don't know. You need a reference sheet. So let me find one here. Let me copy this, share it, go back to the other screen. So if you ever seen like around Valentine's Day when people make, really they make pictures, they're sometimes using polar coordinates. So that looks terrible. Let's find a better one. Um, your book has one of these in there.
Okay, yeah.
I'm gonna spend another minute looking for a better reference than this. This is terrible. There's always a problem. Nobody wants to share their stuff. All right. I don't know. Any questions on that?
No, that makes
Okay. So the next question is on what? What's our next question on? Another graphing? Yep. So it's the
yeah,
same
verify
thing.
that identity.
Oh no, yes, let's do the verify the identity because these are more involved. And you're saying you haven't done these or you're not, or you have, you just don't know how to do them.
Yeah, I just don't remember.
Okay. So there's you have to pick a side to work on. And it's like you either make the left look like the right or the right look like the left. You can occasionally work on both sides, but it's better to just pick a side. And it's kind of odd. You actually pick the more complicated side in general to work on. Now this one's actually not super difficult, but the sometimes it's hard to figure out which one's more complicated. Usually it's like things with fractions are more complicated than things without. So we're gonna work on the left side. Is that okay?
Yeah.
All right. Now there's a bunch of strategies. Just because I guess I'll sort of give you one. One is just to break it apart like this. What is and turn everything into a sine or a cosine. So from the reciprocal identities, you know that 1 over cosecant is really sine x, and 1 over secant squared is really cosine squared x. Now it's the same. Some teachers want you to like flip the order. But that's it for this one. This one's not very involved. They can become extremely involved. Like 38's a little more involved. You want to do 38 next?
So verifying the identity, the answer would be
You're just showing the work on the left-hand side.
okay. And then, what'd you say?
Do you want us to do the next one?
Yeah.
All right. So the next one is a little bit more involved. Which side looks more complicated to you? Let me get it snipped in here. Does the left side or the right side look more complicated to you?
Left.
Yeah, so we're gonna work on that. So there's a bunch of ways to proceed here. Like I said, one way is to turn everything into a sine and a cosine. So secant's really 1 over cosine x, but that doesn't really do anything with the sine squared. However, whenever you see a squared, you want to think Pythagorean identity. Do you know what I mean by those?
Um,
So there's
oh,
three
really?
of them. There's 3 Pythagorean identities. Let me snip those in. Okay, these are the Pythagorean identities. Do those look familiar to you?
Yeah.
All right. So we're going to solve the first one for sine squared theta or sine squared x. You can always switch the letter. Okay. So what what is it when we solve for x? Or solve for sine squared x? What does this become when you solve for sine squared
1
x?
minus cosine squared x.
Yeah, that looks good because we already have kind of a cosine there. So sine squared x is 1 minus cosine squared x times 1 over cosine x plus cosine x. Is that okay so far?
Yeah.
All right, so now we're gonna slide this cosine x underneath both of these. So it's 1 over cosine x minus cosine squared x over cosine x plus cosine x. So sometimes it gets worse before it gets better. Sometimes my handwriting gets worse before it gets better. That's pretty bad. Sorry. So, um, now, do you see that 1 over cosine x is a secant x?
Yeah.
Okay, that's a good thing. We're like, all right, we're moving kind of in the direction of what we want. What do you see here in this middle term? Cosine squared x over cosine x.
Cancels out to 1 over cosine. I mean,
Yeah,
cosine x.
yeah. So this becomes just cosine x, like with the one of them on the top cancels with one on the bottom, and then you've got minus cosine x plus cosine x, so those cancel, and then it equals secant x like that.
Okay. Yeah.
All right. Any questions on that?
That makes sense.
You want us to do another one here, the last 139?
Yeah.
Okay. All right. So when you look at this one, which side do you feel like is more complicated, the left or the right?
The right.
Yeah. And one of the things you notice, like it's easier to go from a square to a single power than to like hold it back up to and increase the power. Um, Whenever you see squareds, you should again think Pythagorean identities. That's a good indicator. So question is, should we convert cotangent squared into cosecant squared or cosecant squared into cotangent squared? Or this last one here. And both are correct, by the way. It's just, maybe there's a certain way that you see it.
Convert cosecant squared to 1 plus, I mean,
Yep,
minus
that's
1
fine.
minus cotangent squared.
Okay, so are you wanting to substitute in for cosecant squared as is or substitute in for cotangent squared? That's kind of what I was asking. Like right now
Cosecant
we could
squared.
sub, okay, so this becomes minus 1 plus cotangent squared. Like that. Is that okay?
Yeah.
Put an extra square in there. Plus sine x. Okay. So that becomes cotangent squared x minus 1 minus cotangent squared x plus sine x. And these cancel. So we've got the minus 1, right? So we got the minus 1, but we don't have that. So that's an example where sometimes you got to work on both sides. So one strategy is to convert everything to sine and cosine. So the tangent becomes sine x over cosine x.
So then it becomes sine minus 1.
Yes, and that's what we want. Now, I've made these look very easy, and they're not meant to be difficult. But if you go down the wrong path, you just restart. Completely restart, turn the paper over, try again. It's hard to figure out your mistakes. Sometimes you make a sign error. These can be very frustrating as well because they're basically proofs. They're like you just proving that they work.
Mm-hmm.
Okay, we got some time left here. What else would you like to look at today?
Can we do another bearing problem?
Sure. Do you want us to do like something like a law of sines, cosines? Do you care?
Uh, I'm fine with either.
Okay. All right. So let's say ship A is going 36 degrees north of east. Or is that the same language you were using?
Yeah.
Okay. Yeah, it is. Okay. Um, and then let's say it turns. We'll make this one different. It turns. So let's draw it here. So this is 36 degrees, and then it turns. Uh, no, that's gonna be too. That's gonna be too. Do you think it'll be like this problem, or should I make it very different?
Do I think it's like what?
Well, I'll just make one. So let's say ship B is going north 48 degrees west. So let me draw this. This is now going the other direction. Okay. And let's say we know that this is 20 and this is 25. Can you calculate the distance between them?
Calculate C. Are the angles near C 90 degrees?
Do you know this whole angle?
Yeah.
So this is a law of cosines problem.
30.34.
That is correct. Now, if you were to calculate, let's say I wanted you to calculate angle A, how would you do that? And would you use law of sines or law of cosines?
I would use law of sines.
So sine A over 20 equals sine, whatever 48 plus 36 is, I guess that's 84 over 30.34. So could you solve that for A for us, please? All right, Akshara, do you have an answer for me?
I plugged in the calculator wrong, but one sec.
All right.
Is it 40.96?
And if I asked you to find the other angle, would you maybe ask for another prop?
180
Yeah,
subtract.
exactly. Exactly. All right. Well, how do you feel now heading into your final?
I feel a lot more comfortable with the concepts.
Excellent. All right.